Hey guys, welcome back to ITower. Today we're building our own Redux from absolute scratch. No libraries, no dependencies, just pure JavaScript. And here's what's cool about this. Redux seems intimidating with all its boilerplate and terminology, but the core implementation is actually shockingly simple. We're talking maybe 50 lines of code to get all the essential features working. We're building a complete state management system with actions, reducers, middleware, and subscriptions. Everything you need to manage complex application state. This matters because state management shows up in every serious JavaScript project. Whether you're interviewing at a tech company or debugging production issues, understanding how Redux actually works gives you a massive advantage. You'll stop just using the tool and start really understanding it. Plus, these patterns apply everywhere. The observer pattern, functional programming, immutability. This is fundamental computer science that will level up your entire development game. Quick request before we dive in. If you want more deep dives into how popular libraries work under the hood, smash that like button and subscribe. It helps us reach more developers and keeps these technical videos coming. Really appreciate your support. So what is Redux actually doing? It's a predictable state container. Your entire application state lives in one central store as a single JavaScript object, but you can't just modify it directly. Instead, you dispatch actions. These are plain objects describing what happened, like user logged in or item added to cart. Actions get processed by reducers, which are pure functions that take current state and an action, then return new state. Never mutating, always returning fresh copies. Why this whole ceremony? 3 huge reasons. First, predictability. Every state change flows through the same path, making debugging trivial. Second, time travel debugging. You can replay actions to see exactly how your app reached any state. Third, testability. Pure functions with no side effects are incredibly easy to test. Redux brings order to the chaos of state management. The architecture has 3 core pieces. The store holds state and provides 3 methods. GetState returns current state. Dispatch sends actions for processing. Subscribe registers callbacks that fire on state changes. The reducer is your pure function that processes actions. And middleware sits between dispatch and reducer, letting you add logging, async handling, or whatever cross-cutting concerns you need. Middleware can inspect actions, modify them, dispatch more actions, or even block them entirely. The beauty is its simplicity. Action comes in, middleware processes it, reducer updates state, subscribers get notified. That's the whole flow. This pattern has been implemented across countless languages and frameworks, because it just works. Let's build this thing. We start with our main function that creates the store. We call this function createStore because its sole responsibility is creating and returning a store object. It takes a reducer parameter. The reducer determines how every state change happens. We require it as a parameter because a store without a reducer can't update state. Now we initialize our state variable where the actual application state will live. We use lat because this value changes over time with each action dispatch. We start with undefined because we'll get the initial value from the reducer when we dispatch the initialization action. We need an array tracking all functions that want notifications on state changes. Empty array initially because nobody has subscribed yet. As the app runs, components subscribe by adding callbacks here. Then we notify them when state updates. We also need middleware tracking. Starting empty because middleware is optional. If someone adds middleware, these functions will intercept actions before they reach the reducer. Now we dispatch a special initialization action immediately when the store is created. This forces the reducer to run with undefined state. The reducer returns its default initial state, which we store. The special action type ensures user code won't accidentally match it. The getState method just returns current state. We need a function rather than exposing state directly to prevent direct mutations. This maintains Redux's predictability by ensuring state only changes through actions. Next is subscribe, which implements the observer pattern. The listener parameter is a callback function invoked every time state updates. Components use this to trigger re-renders. We add this listener to our array using push to append the listener. Now it'll be called on every state update. Subscribe returns an unsubscribe function to prevent memory leaks. When components unmount, they must unsubscribe. Filter creates a new array without the unsubscribe listener. Now dispatch, the heart of Redux where all state changes happen. Actions are the only way to trigger state changes. By funneling all changes through dispatch, Redux maintains predictability. Let's validate the action is actually an object. We check action isn't null or undefined, and that it's an object. Failing fast with clear errors helps users fix mistakes immediately. We validate the type property exists. Type is mandatory because reducers needed to determine what state changes to make. Now we create the base dispatch function, the core state updating functionality. This is the innermost function that middleware will wrap. When middleware finishes processing, this runs. This is where state actually changes. We call the reducer with current state in action. The reducer returns a new state object which we assign to state. The reducer never mutates existing state, always returns fresh copies. After state updates, we notify all subscribers. For each loops through every listener and invokes it, this triggers component re-renders. All listeners are notified synchronously before dispatch returns. Now we build the middleware chain. We start with base dispatch. If there's no middleware, we're done. Otherwise, we'll wrap it with each middleware layer. We loop through middleware in reverse to build the chain correctly. Going backwards ensures the first middleware added becomes the outermost layer and executes first. Inside the loop, we wrap the current dispatch. We save current final dispatches next, then call the middleware with getState and dispatch access, and pass it next. This builds layers like an onion, each middleware wrapping the previous one. Finally, we call the constructed dispatch chain. The action flows through each middleware. If all call next, it reaches base dispatch where the reducer runs. We return the action for potential chaining. Redux returns the dispatched action, allowing patterns where you reference the action just dispatched. Now the apply middleware method. Using REST parameters to accept any number of middleware functions. We push all provided middleware into our array. Pred operator adds all middleware to the array. Finally, return the store object with all methods exposed. These 4 methods are the complete public API for interacting with the store. Let's create Logger middleware to demonstrate how middleware works. Middleware takes the store, getting access to getState and dispatch. It returns a function taken next. Next is the next middleware in the chain or base dispatch if we last. This returns the actual action handler. This function executes when actions are dispatched. Logs action before processing. GetState before the action processes. Call next to continue the chain. Get the updated state after processing. Log both states for comparison. Return the result to maintain the chain. The middleware logs everything without interfering with normal flow. Now let's test everything. First, we need a simple counter reducer. This handles increment, decrement, and add actions. Default state starts at 0. Create the store with our reducer. Apply our logger middleware. Now, every action gets logged automatically. Subscribe to state changes. Let's dispatch an increment action. Looking at the console, we see the logger output and state change to count 1. Another increment. Count is now 2. Perfect. Test the add action with payload. Count jumps to 7. 2 plus 5 equals 7. Exactly right. Try decrement. Count drops to 6. Verify final state. Shows count 6. Everything works perfectly. Our homemade Redux handles actions, processes them through middleware and reducers, and notifies subscribers. There it is, a fully functional Redux implementation in about 50 lines of code. We built a store holding state, dispatch processing actions through middleware and reducers, subscribe for reactivity, and middleware support for cross-cutting concerns, all without any external dependencies. Redux isn't magic, it's elegant design built on simple JavaScript. We learned the observer pattern through subscriptions, functional programming through pure reducers, and chain of responsibility through middleware. These are fundamental patterns appearing everywhere in software engineering. The practical value is massive. You now understand exactly what happens when you dispatch actions in real Redux apps. You know why immutability matters. You understand how Redux Tongue and Redux Saga work. You can debug state issues effectively and make informed decisions about when you need a full library versus a custom lightweight solution. This knowledge applies to Vuex, NGRX, MobX, Zustand, and every state management library, because they all solve the same core problems. That's it for today. If you enjoyed this deep dive, hit that like button and subscribe for more content breaking down popular libraries and frameworks. Thanks for watching, and see you in the next video.